The Aldebaran Theory, A Bible of Coincidence. By Mark Salat. Chapter 1, Section A. Introduction to Aldebaran, former home of the earthly gods. Taurus is a large and prominent constellation in the northern hemisphere's winter sky. It is the only constellation crossed by all three of the galactic equator, celestial equator, and ecliptic. The identification of the constellation with a bull is very old, certainly dating to the Chalcolithic, and perhaps even to the Upper Paleolithic, very broadly dating to between 50,000 and 10,000 years ago, roughly coinciding with the appearance of behavioral modernity. It came to symbolize the bull in the mythologies of ancient Mesopotamia, Egypt, and Greece. In the early Bronze Age, it marked the location of the sun during the spring equinox. Taurus exhibits a number of features of interest to astronomers. It hosts two of the nearest open clusters to Earth, the Pleiades and the Hyades, known since prehistoric times, both of which are visible to the naked eye. At first magnitude, the red giant Aldebaran is the brightest star in the entire constellation. Slightly before, and during the Upper Paleolithic, Aldebaran would have been observed as being fixed between the horns of Taurus for at least 20,000 years before it settled into its current position as the bull's right eye, to the left from a head-on perspective. The zodiacal signs are an abstraction from the physical constellations, and each represent exactly 1/12 of the full circle, or the longitude traversed by the Sun in about 30.4 days. Taurus is the second astrological sign in the zodiac. It spans the 30th to 60th degrees of the zodiac between 27.25 and 54.75 degrees of celestial longitude. Under the tropical zodiac, the Sun transits this area on average between April 20th to May 20th each year. Under the sidereal zodiac, the Sun currently transits the constellation of Taurus from approximately May 16th to June 15th. In all the ancient zodiacs, Taurus is the beginning sign, and marked the vernal, or spring equinox from about 4000 to 1700 BCE. Astrologically, Aldebaran is a fortunate star, portending riches and honor. It is one of the four royal stars of the Persians, from around 3000 BCE, 5014 years ago. These stars were chosen in such a way that they were approximately 6 hours apart in right ascension. Each of these stars was assigned to a season. Aldebaran was prominent in the March sky, and as such, it was associated with the vernal equinox. Its current celestial longitude is 09 degrees Gemini, 47 minutes as of 2006. The reason why they are called royal is that they appear to stand aside from the other stars in the sky. Throughout a year, each star is dominant for several months in the night sky, and one can guess the season just by noticing which star is dominant. Royal stars are quite rare, although in books they are often mentioned. Aldebaran was also one of the 15 Behenian stars considered especially useful for magical applications in the medieval astrology of Europe and the Arab world. Their name derives from Arabic, Bahman, which means root, as each was considered a source of astrological power for one or more planets. Venus is the planet usually considered to rule Taurus. Within 2 centuries after the Assyrian king Ashurbanipal collected the Enuma Elish, Enuma Anu Enlil, Mul-Apin, and other cuneiform texts into his great library, the Babylonian priest astronomers had made a further refinement of their picture of the paths of the gods. In 2 cuneiform texts dating from 475 BCE, and excavated from Babylon, the zodiacal constellations are divided into 12 30-degree signs. This is the original or sidereal zodiac. Sidereal means pertaining to the stars. The sidereal zodiac is defined in such a way that the star Aldebaran, the bull's eye, at the center, 15 degrees, of the constellation of Taurus, is in the middle of the sign of Taurus, and the star Antares, the scorpion's heart, at the heart of the constellation of Scorpio, is at 15 degrees Scorpio, in the middle of the sign of Scorpio. These two stars comprise the fiducial, or origin of reference axis, the defining axis of the sidereal zodiac, given by the remarkable fact that Aldebaran and Antares lie diametrically opposite one another and are located at the center of their respective zodiacal signs. The Pleiades, or M45, is an open star cluster containing middle-aged hot B-type stars located in the constellation of Taurus. The cluster, located between 390 to 460 light-years away, is dominated by hot, blue, and extremely luminous stars that have formed within the last 100 million years. Measurements of the distance have elicited much controversy. Results prior to the launch of the Hipparcos satellite generally found that the Pleiades were about 440 light-years away from Earth. But data from Hipparcos yielded a surprising result, namely a distance of approximately only 385 light-years, a little over twice as far as the Hyades is from our solar system. In Greek mythology, Taurus was identified with Zeus, who assumed the form of a magnificent white bull to abduct Europa, a legendary Phoenician princess. In illustrations of Greek mythology, only the front portion of this constellation are depicted. This was sometimes explained as Taurus being partly submerged as he carried Europa out to sea. A second Greek myth portrays Taurus as Io, a mistress of Zeus. To hide his lover from his wife Hera, Zeus changed Io into the form of a heifer. Greek mythographer, Akoselos, marks the bull Taurus as the same that formed the myth of the Cretan bull, one of the 12 labors of Heracles. The Hyades were the 7 daughters of Atlas and Ethra, rendering them the 7 sisters to the Pleiades. The Pleiades were the 7 daughters, also 7 sisters, of Atlas and Pleione. They were nymphs in the train of Artemis, and together with the 7 Hyades were called the Atlantides, Dodonides, or Nisiades. English linguist and lexicographer from the late 16th century, John Mincheu, also considered the Hyades the 7 stars, from Ductor in Linguas, Guide into the Tongues, and Vocabularium Hispanico-Latinum, 1617. The Greeks believed that the heliacal rising and setting of the Hyades star cluster were always attended with rain, hence the association of the Hyades, sisters of Hyas, and the Hyades, daughters of Ocean, with the constellation of the Hyades, rainy ones. This is their universal character in the literature of all ages. Hyene is a Greek term meaning to rain, and is believed by some to be directly related to the word Hyades. Ovid, Publius Ovidius Naso, called them Cetus Hyantis, after their earthly brother Hyas. The main myth concerning them is envisioned to account for their collective name and to provide an etiology for their weepy raininess. Hyas was killed in a hunting accident and the Hyades wept from their grief, hence the title Rainy Ones. They were changed into a cluster of stars, the Hyades, and set in the head of Taurus. Pherecydes of Leros is said to have acknowledged Beta and Zeta Tauri, at the tips of the horns. Dione, also known as Semele, mortal mother of Dionysus, and Protis, were supposed to be daughters of Hyas by Ethra and have been added to the group of stars. The Hyades are also thought to have been the tutors of Dionysus in some tellings of the latter's infancy, and as such are equated with the Nisiades, the nymphs who are also believed to have cared for Dionysus, as well as with other reputed nurses of the god, the Lamides, the Dodonides, and the nymphs of Naxos. The Hyades, also known as Malat 25 or Calendar 50, is the nearest open cluster to our solar system, and is one of the best studied of all star clusters. Located at 153 light-years away, its age, about 625 million years, metallicity and proper motion, coincide with those of the larger and more distant Praesepe cluster, and the trajectories of both clusters can be traced back to the same region of space, indicating a common origin. The 4 brightest member stars are all red giants that began life as A-type stars and have now evolved off the main sequence. Aldebaran can be considered a 5th red giant in the Hyades. Epsilon Tauri, also known as Iene, harbors at least one gas giant planet. Bassus and others knew the group as Upsilon, the symbol associated with Pythagoras for human life, and the Roman V, as it resembles those letters, Alpha and Epsilon Tauri being the extremes, Gamma Tauri at the vertex. From the perspective of observers on Earth, the Hyades cluster appears in the constellation Taurus, where its brightest stars form a V shape, outlining the face of the bull, along with the still brighter red giant Aldebaran. Thanks to its ruddy coloring and position among the stars which form Taurus's head, Aldebaran has earned the nickname the Eye of the Bull, or the Bull's Eye. A later Arabic name was Ayn al-Thor, Eye of the Bull, identical with Greek Amabuz, Latin Oculus Tauri, and the early English Bull's Eye. Hebrews rendered this star, God's Eye. Another Hebrew name for this star was Aleph, which was also used for the constellation of Taurus, or at least the Hyades. As first in the early Hebrew zodiac it was designated by Aleph, the first letter of their alphabet, coincidentally a crude figure of the bull's face and horns, some of the Targums assigning it to the tribes of Manasseh and Ephraim, from Moses' allusion to their father Joseph in the 33rd chapter of Deuteronomy, his horns are the horns of the wild ox. However, Aldebaran is completely unrelated to the Hyades, as it is located much closer to Earth, 65.1 to 68 light-years, hence its apparent brightness, and merely happens to lie along the same line of sight, and it shines with 425 times Sol, our Sun's, luminosity. With an average apparent magnitude of 0.87, it is the 13th brightest star in the nighttime sky. From a planet orbiting Aldebaran in its current location, Sol would appear slightly above Antares in our constellation Scorpius, and at magnitude 6.4, would barely be visible to the naked eye. This could potentially provide a deeper significance to the beliefs held by occult aficionados pertaining to the constellation Scorpius, that had until now, not been previously revealed. Aldebaran, classified as a type K53 star, is known as a red giant, although it appears more of an orange color to the unaided eye. The appearance of the red giant is from yellow-orange to red, including the spectral types, K and M. It is believed that red giants are evolved from main sequence stars with masses in the range from about 0.3 solar masses to around 8 solar masses. Over its main sequence life, the star slowly converts the hydrogen in its core into helium. Its main sequence life ends when nearly all the hydrogen in its core has been fused. When the star exhausts the hydrogen fuel in its core, nuclear reactions in the core stop, so the core begins to contract, due to its gravity. This brings additional hydrogen into a zone where the temperature and pressure are adequate to cause fusion, and so fusion continues in a shell about the core. The outer layers of the star then expand greatly, thus beginning the red giant phase of the star's life. As the star expands, the energy produced in the burning shell of the star is spread over a much larger surface area, resulting in a lower surface temperature and a shift in the star's visible light output, towards the red, hence it becomes a red giant. As a star that has evolved out of the main sequence, Aldebaran has fully shifted from the fusion of hydrogen to helium at its core to the fusion of helium to carbon and oxygen, with trace activity of other nuclear processes. This helium burning, orange-red giant stage, is relatively brief, lasting tens to hundreds of millions of years, around 700 million years for a star of 1 solar mass. The core temperature of Aldebaran has greatly increased due to gravitational pressure and has expanded to a diameter of 44.2 times the diameter of Sol. Aldebaran is a slightly variable star, of the slow irregular variable type, i.e., a variable star that exhibits no or very poorly defined periodicity in their slowly changing light emissions, LB. It varies by about 0.2 in apparent magnitude from 0.75 to 0.95, with a near-infrared J-band magnitude of -2.1. 5 faint stars appear, close enough to Aldebaran in its visual field for astronomers to consider it a double star association. These stars were given alphabetic secondary star designations more or less in the order of their discovery, with the letter A reserved for the primary star. Some surveys have indicated that Alpha Tauri b may have about the same proper motion and parallax as Aldebaran and thus may be a physical binary system. However, these measurements are difficult to make because the dim B component appears so close to the bright primary star. This companion is far too dim to be seen unaided. The resulting margin of error is too large to positively establish, or exclude, a physical relationship between the two stars. Star B is believed to be a red sequence dwarf star of spectral and luminosity type, M25. It may have 15% of Sol's mass, 36% of its diameter, and 14 10,000ths of its luminosity. The orbit of an Earth-like planet, with liquid water, around star B, would be centered around 0.036 astronomical units, well inside the orbit of Mercury in our solar system, with an orbital period of 6.5 days. Useful catalog numbers and designations for the star include GL 171.1b, GJ 9159b, WO 9159b, BD plus 16629b, and ADS 3321b, for further inquiry. Aldebaran may have originally been the size of Sol, and may at one time have had its very own planetary system. Any Earth-type planets that orbited Aldebaran during its youth would have been burned to a cinder by now, and would possibly have fallen into the star from frictional drag with the giant star's gaseous envelope, leaving any leftover debris to recoalesce into the object potentially observed in 1997. In that year, a team of astronomers, including R.D.P. Hyades and William D. Cochrane, announced the discovery of a giant planet companion, B, to Aldebaran. According to Hyades in 2008, the most likely explanation for the 630-day radial velocity variations, about 1.8 years, is that they are due to a planetary companion. But the planet is still not published in a refereed journal and can be neither confirmed nor denied. Astronomers would find it very difficult to detect an Earth-sized planet around this star, using present methods. Planet B appears to move around Aldebaran A, with an average separation of 1.35 astronomical units. Its orbit is eccentric. The object has at least 11 times the mass of Jupiter, with a similar diameter, about 11 times that of Earth. If Aldebaran had once housed a planetary system, its destruction and recoalescence would potentially explain the mass associated with the proposed object. It is extremely difficult to confirm the detection of this substellar object around a highly evolved star like Aldebaran, because giant stars often pulsate and produce radial velocity patterns similar to substellar companions. However, because the method of detection relies on radial velocities using the Doppler technique, and only determines the object's minimum mass, companion B may actually be a brown dwarf. If a substellar object was formed the way a star is believed to, from a collapsing cloud of interstellar gas and dust, then it would be called a brown dwarf. If it was formed by gradually accumulating gas and dust inside a star's circumstellar disk, however, it would be called a planet. Once the first brown dwarf candidates were actually found, astronomers realized that it was actually quite difficult to definitely rule on the validity of competing hypotheses about how a substellar object was actually formed, without having been there. In comparison, the evolution of Sol into and through the red giant phase has been extensively modeled, but it is still unclear whether the Earth will be engulfed or will barely survive. However, current research suggests that after Sol becomes a red giant, Earth will be pulled in owing to tidal deceleration. Sol will exit the main sequence in approximately 5.4 billion years and start to turn into a red giant. At its brightest, the red giant Sol will be several thousand times more luminous than today, but have about half the temperature. It is calculated that Sol will become sufficiently large enough to engulf the current orbits of our solar system's inner planets, possibly including Earth. Even before it becomes a red giant, the luminosity of Sol will have nearly doubled, and the Earth will be hotter than Venus is today. Once the core hydrogen is exhausted in 5.4 billion years, Sol will expand into a subgiant phase and slowly double in size over about half a billion years. It will then expand more rapidly over about 500 million years, until it is over 200 times larger than today, and a couple of thousand times more luminous. This then starts the red giant branch phase, where Sol will spend around 1 billion years, and lose around a third of its mass. Although traditionally it has been suggested that the evolution of a star into a red giant will render its planetary system, if present, uninhabitable, some research suggests that, during the evolution of a one solar mass star along the red giant branch, it could harbor a habitable zone for several times 10 to the 9th power years, at 2 astronomical units out, to around 10 to the 8th power years at 9 astronomical units out, giving perhaps enough time for life to develop on a suitable world. After the red giant stage, there would for such a star, be a habitable zone between 7 and 22 astronomical units for an additional 10 to the 9th power years. Aldebaran is close enough to the ecliptic to be occulted by the Moon, and is presently only possible by the Moon because the planets pass Aldebaran to the north. Such occultations occur when the Moon's ascending node is near the autumnal, fall, equinox. This event will next occur around 2015. A reasonably accurate estimate for the diameter of Aldebaran was obtained during the September 22, 1978 occultation. On March 11 to 12, 509 AD, an astronomer in Athens named Hipparchus recorded an occultation of Aldebaran by the Moon. More than a millennium later in 1718, the English astronomer Edmund Halley, most famous for the comet named after him, calculated that this could not have happened unless Aldebaran was in a slightly different position in ancient times than from its location in 1718. It was only a small discrepancy of a few arc minutes, but it was the first, post-Dark Age evidence, that the fixed stars in the sky actually move relative to each other. Not only is Aldebaran moving slowly across the background of distant stars, but it is also moving away from the Earth and our solar system very rapidly, at 33.554 miles per second. That's the fastest proper motion of any of the brightest stars, and is enough to cover a light year every 5,600 years. With today's computer technology, even the layman astronomer can ascertain that in the time subsequent, and approaching 330,020 years ago, Aldebaran was the brightest star in the night sky, at a distance of 21.5 light-years from Earth, outshining even Sirius. Sirius was 25.2 light-years away at this time, a difference of 3.7 light-years. Aldebaran wasn't yet part of the Hyades, due to its being located in a position relative to that of Polaris, towards the north. Since then, it has been shown to have a southward proper motion. Over the course of the next 280,020 years, it gradually settled into a position that could be considered a part of the Hyades as the bullseye. It is currently located, right ascension 4 hours 35 minutes 55.2 seconds, plus 16 degrees declination at 30 hours 33 minutes, and is one of the easiest stars to find in the night sky, partly due to its brightness and partly due to its spatial relation to another of the more noticeable asterisms in its vicinity. If one follows the 3 stars of Orion's belt, Alnitak, Alnilam and Mintaka, from left to right, in the northern hemisphere, or right to left, in the southern, the first bright star found by continuing that line is Aldebaran. HipLiner software can simulate the position of stars spanning millions of years using 3D proper motion data from the Hipparcos satellite's main catalog and Hipparcos input catalog, for radial velocity. The free software can be downloaded here. For further inquiry, http://t.nomoto.org/hipliner/index-e.html. To be continued, in Chapter 1, Section B. Thank you for listening.